All right, so in this video, I'm going to go through graded potentials. All right, so the first thing that we need to understand is we've talked about membrane potential. Okay, so this is a figure here. So we've got membrane potential. All right. Normally, and we're going to talk about this more in upcoming topics, our resting membrane potential is around -70. We've actually talked about that, right? And so our resting membrane potential is here. And then what will happen is something will change, and we'll get to that, um, where we hit what's called threshold. And so this threshold is actually at -55 millivolts. And so some sort of thing here happens. And this part right here is what we refer to as it takes a graded potential. So to get from here to here requires a graded potential. Okay. Now, once we hit threshold, then an action potential actually occurs. And so it looks something like this. Okay, and there's three parts. So you've got depolarization, which just means less negative. D is less, polarization is negative. Okay, and so that's from here to here. Excuse me. Then we've got repolarization, which is from there to there. Okay, so repolarization just means return to our original negative state. So return to negative. And then we've got from, and I didn't draw it really well. So let's fix this real quick. So we've got our hyperpolarization, something like this, right? And so with hyperpolarization, we're from that pink X to here. So this is hyperpolarization, which means more negative. Okay. And we'll get into what causes each of these three stages, I believe, in the next video. So I think after graded potentials, we talk about action potentials. But for this video, I'm going to focus specifically on graded potentials. Okay. So a graded potential is just a small temporary or small short lasting change. Okay, when we're talking about membrane potential, all that's happening is we're opening or closing doors on the membrane. Okay, and when we open or close doors, it changes what's inside the cell. So let's just, to keep it simple, let's just say that we're going to just open doors. Okay, and so there's going to be some sort of stimulus which is going to lead to channels or doors opening. And remember, ion channels are specific, so channels open. Okay. Now, in order to, excuse me, with graded potentials, we can have two types. We can have, so two types. So we can have, keep telling Siri, okay, so two types. So we can have an excitatory, and you'll see them sometimes abbreviated as EPSP, excitatory postsynaptic potential. Excitatory graded potentials are also depolarizing. Okay, so depolarizing. Then you've got inhibitory or IPSP, so inhibitory postsynaptic potentials. These are hyperpolarizing. Okay. Now, in order to determine if something is excitatory or inhibitory, we need to know two things. And so those two things are the ion charge and the direction. Okay. So when you think about it, there's only four combinations here. So you can have a positive ion, a negative ion. You can have influx or efflux. Okay, so we're going to make our little table here. There we go. Okay, so if we have a positive ion going in, that's going to depolarize the membrane potential, so that's excitatory. If we have a positive ion going out, that's going to be the opposite, so that's inhibitory. An example of this would be sodium, normally goes in. An example of the inhibitory one would be potassium, normally goes out. If we have a negative ion going in, that's going to be inhibitory. An example of this, although we won't really talk about it in this class, would be chloride influx. And then an example of or if a negative ion leaves, that's also excitatory. Okay, so an example of that I think would be bicarbonate efflux. Okay. All right, and so once we know that, we know if the graded potential is inhibitory or excitatory, or is it depolarizing or hyperpolarizing. Now, when you have signals sent from one cell to another, from one neuron to another, a single graded potential is not enough to get us to threshold. It takes many, many, many graded potentials to get us there. Okay, and so this is where the concept of summation comes from. Okay, and summation is exactly what it sounds like. It's just summing or adding graded potentials. And we can break these up into two parts, or two types, excuse me. So you've got temporal and we've got spatial. Okay, temporal has to do with time. Spatial has to do with space. Temporal is one neuron sending the signal. Spatial is multiple neurons sending the signal. Okay. Now remember that earlier, I'm going to scroll back up here to the top. I thought I put it somewhere. Okay, yeah. Graded potentials are small, short-lasting changes in membrane potential. Okay, so how does this work? Well, with temporal summation, you have one neuron sending lots of signals really fast. So sending repeated signals in quick succession. Okay, and so what I mean by that, or what happens, okay, so let's just say, so here's our time, here's where we're at, this is threshold. So what happens is a neuron sends a signal to a second neuron. So the second neuron's membrane potential does something like this. Okay, that's just one graded potential. Nothing happens. It's not, it changes membrane potential, but it's not enough to get us to threshold. Well, now, if we have temporal summation, what happens is that we have that. Now it starts to decrease, but we have another signal. It's trying to do this cool, make it look pretty. And it keeps doing that. And then eventually we hit threshold. And once we hit threshold, an action potential occurs. Okay, you can't stop an action potential from occurring once we hit threshold. But this right here would be that temporal part. Okay, so the first neuron is sending a signal before the second neuron gets back down to its resting potential. And so we have these little jumps, these little bumps. And so that's temporal summation. Okay. Then we've got spatial summation. And so spatial summation is similar but different. Okay, so in this case, so again, here we're at resting potential. We have one neuron send a signal. That's where we get. Well, with spatial summation, what actually happens is we might get this big jump like this because we get, so right here, this would be spatial, because lots of neurons are sending a signal at the same time. And so we add up all of those and we hit threshold. So just imagine that. Okay, so we're trying to get from negative 70 to negative 55. Well, let's say that, and we're just making stuff up here, but let's say that each neuron causes a membrane potential change of +1, right? So if we go +1, well, negative 70 plus 1 equals negative 69. Okay, well, we're not at threshold. Okay, so nothing happens. We'll go back down to that negative 70. But now let's say that if we're at negative 70, but we have 15 neurons send excitatory signals all at once, and each of those causes a 1 millivolt change. Well, now negative 70 plus 15 times 1 equals negative 55. And we've reached threshold. And with that, we have an action potential. And so those are the basics of graded potentials. I hope that this has helped you out.